Hey everyone, let's solve the second problem from Biweekly contest 89, that is range product queries of powers. Given a positive integer n, there exists a zero indexed array called powers composed of the minimum number of powers of 2 that sum to n. And the array given is sorted in non-decreasing order and there is only one way to form the array. We are also given a zero indexed 2D array called queries, where queries I, left I to right I. Each query represents a query where you have to find the product of all powers from left eye to right eye, and we have to return an array called answers equal in length to queries where answers I is the answer to the ith query. Since the answer to the ith query may be too large, each answer size should be returned modulo 10 raised power 9 plus 7. Now let's see what the question means. Basically we're given this number n, right? So what we want to do in this question is, right, so there is another zero indexed array called powers. Now we want to make this array called powers, and this array powers contains how many powers are required to make this number, right? So the powers that are required are 1, 2, 4, 8, right? So this is 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 4. So we can make this n by adding these numbers, right? So we have to take these numbers and the queries will be between 0 to 3, and then what we want to do is we want to basically iterate into these queries, right? Just like given into this question, what we will do is we will multiply queries from 0 to 1. We will multiply these, right? We will create a vector called answer and an array called answer, in which we will multiply these two first query, right? So we'll get 2, and then the second element will be multiplying these 2 to 2, so which is 4, right? And then we will have to multiply 0 to 3, right? All these elements, so which will give 1 into 2 into 4 into 8, which is 64. So this is the array that we want to return. So the first thing is we want to create this powers array, in which we have to have powers only until this number, right? Until we get a number n, right? By adding all these powers. So that is what powers array will contain. That is these the powers of 2 that we have added, right? And then we have a queries array. We have to iterate into this queries array, and we have to multiply the elements from the powers array, and we have to put them in another array called ans, and we have to return this answer array, right? So it's an easy problem, right? So let's see the code of it. So basically what we have done is we have taken one vector called ans and one vector called v. So now how are we reversing, and how are we creating this vector v, right? So this vector v is actually the problem vector that we just discussed. Let's see how we are creating this vector, right? So we are iterating till only 2 to the power 30. Now why are we iterating to the power 30? Because in the question it is given to us that n is between 1 to 10 raised power 9. If n is between 1 to 10 raised power 9, that means n is between 1 to 2 raised power 31. Alright, so we have to take all these bits, right? So we are iterating from 1 to 30. Okay, now what does this line means? Why are we doing this, right? Why are we not keeping a variable and adding? This is essentially basically what we are doing is we're saying that, take one and left shift whatever the number is given to us, whatever the power is given to us, and do and with the number given to us, right? That is what this is saying, right? Now why it is saying this is, obviously the binary numbers are in the powers of 2 only. So let's say to build this numbers we had to take 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Now we don't have to take 16, right? We don't have to take 16. So this is 16 is 2 to the power 4. So what is the binary representation of 16? It is this, right? And what is the binary representation of 15? It is this, right? So if we do the bitwise AND of these two numbers, what we will get? We will get 0. So that means we don't have to push this value, right? That is 4 into our v vector, right? So that is what this line is doing here, right? And then we are iterating into the queries array, right? And we are taking the first query to the last query, and we are multiplying them into a variable. And also we are taking this mod because by multiplying such large values, we will be getting a very large value which we cannot store, so we have to return the answer modulo this. So we have taken this into this a mod variable, and then we are doing mod of it here only, because there is no point of taking the variable and then after we have calculated the whole thing and doing the mod of it, that might result in a wrong answer. So we have to do it here only, and then we are pushing it into the answer vector, and that is what we have returned.